So in this demo, we look at scaling a consumer Kafka consumer application which is deployed to GKE Autopilot utilizing Keda. Right, so Keda is also deployed on GKE. Now there are multiple screens you see here. The screen where I am at the moment. So here I'm watching the pods, right? So as soon as I will start sending the data to Kafka, you will see that the pods will start to come up, right? There is already a deployment deployed here, but there are no pods running, right? So this is something that Keda supports, that scaling down to zero, right? Which is otherwise not possible. So there is nothing running because there is no data being generated. Now on the Kafka side, this is Confluent uh, cloud I am using. Now there are topics you can see. So there are two topics, and this is the one I'm going to utilize. Keda on GKE. It has 12 partitions, right? Now one of the significance of the partition on Kafka is that the number of partitions will dictate what the parallelism that you're going to get. Right? So if I have 12 pods running, that is okay for a topic which has 12 partitions. But if I have, let's say, if I want to run 20 pods here, but the partition count is still, let's say, 12, that's not going to go through, right? So each partition gets one dedicated consumer, right? And within a consumer group. So this is the topic I'm going to use, and let's look at the clients. So there is a generator app, and we're going to measure the consumer lag. Right? This is available on the consumer lag is nothing but how far behind the messages our consumers are. So this is the group number 8 is the one that I'm going to use. Right now there is 0 because nothing is coming in, nothing is becoming. So I'm going to start this generator here. So what this generator is going to do, it's going to send data to the Kafka topic every 3 seconds, right? So this is what we are going to start with. Now once you start, and then later on we will increase the speed to about maybe about 200 records per second or so, and we will see that this application will scale on this window, and side by side you will be able to see the backlog being created in the Kafka. Alright, so you can see that the generator has started, and we can see the backlog being created, right? So there are 3 records already, now 5. This is so because the consumers have not come up yet, right? They are being created as soon as the data starts to come in. Keda has started our pods, right? So this is the first pod that has been created. So now this pod is running. You will see that we are able to consume the messages as and when they are coming in. So in this window, I'm going to increase the speed now. So here the 100 means one record every 100 milliseconds. So that is in a second. I'm going to send every 10 records, right? So let's see what happens. So you'll see that the backlog will start increasing, but our one consumer will be able to handle this load, right? This actually is nothing. So we'll let it stabilize. Yeah, so we can now go ahead and so this is 20 milliseconds. So that means we are going to send about 50 records every second. You would see that this is increasing, but simultaneously Keda has started our next set of pods, right? So the new one has come up. So now we have at least 2 pods running, right? One is this one, and another is this one, right? So you can see this is D7W and this one is HCH, and wow, and there are more coming, right? So let this stabilize. So as soon as this will come up, you will see that this number will come down slowly. We can also see how many pods have come up. All right, so there is this one running and there's this one running. Right, so two are running and rest of being are being created. Now there is one challenge I've been facing. I'm struggling with the quota, but whatever number comes up, I think now you know that Keda is able to scale, and we can go a little bit more faster here. So this will increase up to 100 records a second, and you can see that the pods have started running now, and we can see some more pods here. All right, so there are now multiple pods running. You would see that this number, keeps coming down, and now when this number goes up here, it means there is another pod which has changed the state. So what that means is there is a shuffle managed by the Kafka, right? So whenever there is a state change to the consumer, it will take some time to shuffle the partitions among the consumers, and that is when you will see that there is a sudden spike and then it will come back again.